Okay, good morning everyone. How are we? Good to hear. Looks like we've just got a few more people coming in, but I'll get started. My name is Jim Pelletier. I'm a software developer from Melbourne, Australia. It's really exciting to be over here for me. I've been a software developer for about 10 years or so in Melbourne all of that time, mainly working in the web development space, C# mainly, with obviously JavaScript and that sort of thing on the front end. A lot of that time I've spent working with teams, and a lot of that time I've spent working with sometimes new stuff, but a lot of legacy code as well. So today I'm going to talk about a tool called NDepend that I've used recently to do some static analysis on legacy code and how that helped a team I was working with lately. I've got about pretty close to an hour's worth of content today, so there's not going to be a lot of time for questions at the end, maybe only 5 minutes or so. That being said, there are a lot of lulls in the talk where I'm going to be doing live demos. I'm more than happy if you want to raise your hand if I don't see you yell out to stop and take questions along the way. I'm also going to try very hard to not get carried away and let my Australian accent take over too much, so hopefully you can all understand me. Again, if there's times that are hard to understand me, I'm more than happy to have someone ask me to repeat what I've said. So what we're going to go through today is I'm going to talk a little bit about how over my career I kept coming back to trying to use NDepend. And what it was that I was trying to do with it. A little bit of a quick tour around the tool itself, just to give you a brief familiarity with the tool. Who's actually used NDepend before? Okay, so maybe a little less than half. So it'll be good just to give everyone a brief overview of what the tool can do. Then I'm going to talk to you about a specific problem that I was solving with a team recently, where we had a big mess of code that we inherited that we needed to improve, and how we use the tool specifically to do that. So just talking about how NDepend kept coming into my life, I guess over the years, I've always tried to work on greenfield projects especially when I was younger. It was something I was really excited about because these are the projects where we can choose new tools, technologies, and techniques that allow us to build features faster, and build a lot of value while also maintaining the ability to change quickly as we discover new things about our users and the requirements and how we want to build things and that kind of stuff. And it's just sometimes I found a little bit more fun. But over time, I've come to realize that while the greenfield projects and choosing all the latest tools and technologies are great, legacy code bases are always there. They're usually the code that is actually generating most of the revenue for the business or providing most of the value at the time. So even if you're building the next big thing, that project's being paid for by a legacy code base that's making money now. So not only are these really important pieces of code, but you often need to understand them very well in order to either replace them or pull them apart or improve them. So I think what I've learned over time is that it's really important to respect the legacy code and also understand not only how to build new and better software, but how to improve and protect the code that we have. So this is where NDepend is. Basically, at a really high level, NDepend is a tool that you can use to query your code base. It's a tool that I mainly knew for its ability to write rules around code that tell you when someone's doing something wrong or when someone's checked in some code that breaks a rule. It's been around for a really long time, and it's something that in sort of my 10, 12-year career, I can't remember a time when we sort of would get frustrated and someone wouldn't say, hey, try NDepend. I suppose what generally would happen is a code base tends to grow, right? Someone writes some code, puts it into production, and then someone adds another feature and adds another feature and then repurposes another feature, and it slowly grows and grows and it slowly tangles up. Add time to that equation of not just the code growing, but people moving on, teams naturally churning, new techniques and tools coming into play. And what often would happen is a new group of developers would find themselves dealing with a code base that someone else had written when different techniques were in vogue. when different decisions were made and for reasons that no one knows anymore. And this is when people sort of start to, to frown a lot more and start to go, why did they do it this way? And make it really hard to understand. And this is where the despair starts to set in. And this is the part where someone would normally go, hey, maybe NDepend can help you with that. Does that sound like a familiar story to anyone? There's a few nods. So that's the idea, that NDepend can help you untangle that sort of stuff. What would usually happen at this point is that I would download NDepend's trial, as they have a 30-day trial on the website, and I'd quickly become overwhelmed. NDepend's a really powerful tool. There's a lot in the box, especially if you download it, install it, and point it at your existing legacy code base, and there's going to be a lot of problems there. So I definitely, I think for the first 2 or 3 times I tried to use this tool, really failed to get any value from it and succeed in making any improvements. So it wasn't until really recently when I was working with a team who basically had a single class with tens and tens of thousands of lines of code in it. And basically we wanted to understand how to break that up and make that more understandable and more usable for us. That combined with the fact that I had to prepare for this talk, where I finally sat down and read all of the documentation. Spent a while doing that. Did I really start to come to understand the tool? So what I'm hoping to do today is give you an overview of both the knowledge that I gained by reading all the documentation, so that maybe you don't have to, as well as I'm going to do a little simulation of that spaghetti mess of that giant God class that we broke up as a team, and show you how we went about doing that. So just moving briefly into a quick overview of what's inside NDepend. As I said before, and as I'll show you in a minute, NDepend at its core is a tool to query your code. So you can do things like, give me all the methods that are named this. So you write the queries for your code, and with that, you can turn those queries into either rules, quality gates, or trend metrics that you can track over time. So all of those are driven by queries. As such, there's a number of visualizations that you get with NDepend, which are also driven by queries. So you select a number of code elements of some kind, and then you can view various metrics of them or see how those code elements depend on each other. And there's a couple of ways to view those dependencies. So what I'm going to do today is I'm going to load up an old open source project that's sort of had some time to grow, so we can show you something that's sort of a real world scenario. So NUnit's a unit testing library that I'm sure a lot of you will be familiar with. And I'm going to show you a little quickly around that. Okay, so I've got NUnit open here. You can see it's got a bunch of assemblies. And I've got NDepend installed, which is a Visual Studio extension. So up here, I actually need to attach NDepend project to the current Visual Studio solution, and I have to basically show it the assemblies. NDepend takes assemblies, source code, PDB files, and a couple of other things into account when it runs its analysis to do the kinds of things you're about to see. So for this particular, sometimes you can just add it from the solution. I'm actually going to add it from the assemblies because NUnit's got a slightly different build structure. So it's got a binary folder in the source root there, and I'm just going to choose the .NET 4.5 one. So we select the assemblies and start the analysis. You can see it sort of just runs through like a build process. In the bottom right-hand corner down here, you can see a little progress bar. And once it's done, we can start to have a look through. So it pops up a little HTML report. I'm not going to look at that today. What I'm going to show you through is the dashboard, which is in Visual Studio. So as that loads, we can basically see that when the analysis was run, roughly the size of code it analysed, what all the types are, how many assemblies and all that sort of stuff. It's got some interesting things. It's got some ideas on how it calculates debt. This thing says it's got 89 man days of debt, which is an interesting little metric. I've not really played a lot with that. You can also see that it's got this baseline here, same project. So I've only done one analysis on this project so far, but you can do multiple analysis over time, and you can see, you can choose the baseline to compare it to, so you can start to do comparisons between what the code looks like today and what it looked like during a previous analysis. But today I'm just going to show you around quickly. So I'm just going to click on this. This is saying there's 4 failed quality gates. If I open it up, all I really wanted to do was just show you that this opens the Queries and Rules Explorer. So this is really the heart of what NDepend does. It queries code. So if I did something like open this object-oriented design and opened a query that said avoid interfaces that are too big, we're going to have this over here, and I might just see if I can zoom in on that for you. So what we're looking at here, if I can stop this moving, is the heart of what NDepend does. It just queries code, right? So what you're looking at is something that's very much like LINQ. In fact, the syntax is exactly the same. But what NDepend does is it provides you with the object model to query over to look at your code. So this is from I in types that are mine, so just my code type. So it provides sort of that sort of thing, and then you just write a LINQ query. So this is obviously a reasonably complicated query to decide if a method is an interface is too big. You can see there it's sort of saying where the methods are more than 10. And then it creates this little object to output, and it comes down here and says basically I matched 5 types that are interfaces that are too big. From there, we turn this into a rule by just adding this little warn if statement at the very top. And so that rule is going to fail or warn you if more than none of these break the rule. So just opening these again, we've got a query. We defined a rule by adding the warn if statement. You can do things like add, you see it says there fail if, so that's going to actually be a quality gate. You can use those to fail the builds. And then the last kind of rule is these trend metrics. So let's see, code size. So we might have some trend that just defines the sum of the number of lines of my code. Trend metrics are different to rules or quality gates in that they will be able to be shown in these sorts of graphs down here, which we don't have any lines on at the moment because I've only done one analysis of this code base. So that's what the queries and the rules look like. Just moving on to some of the visualizations. I've just clicked on this number of types over here, and it's brought up a query that has just shown all the types. So I've got almost 1,500 types in this. There's a little button here that says export to graph. So actually, let's not do that one. It's going to be way too big. Let's do the number of assemblies. All right, so 9 assemblies. Then I can export that to a graph. And then that'll graph these with the dependencies between them. I can choose whether the size of the box is based on the number of IL instructions or the cyclomatic complexity, whether the edge thickness is dependent on the number of dependencies between methods or members and that kind of thing as well. So we can then do things like modify this graph. If you were to zoom in here, I'll just get rid of this so we can see it a little better. You can see that one's some kind of system class that's accidentally been picked up. We might not want that in there, so I can remove that manually. You can also actually go back and edit that query manually to maybe constrain via the namespace that it's in or the string that the name is or something like that as well. You can zoom in, sort of right-click on there and view the internal dependencies of that. So I've gone from the assembly level down into the namespace level. And if I go even further, I can go into the type level. So this is the graph of the types inside this project. And as you can see now, it starts to become a little bit useless. And this is also one of the hurdles that I often hit when I was trying to use NDepend. If you try and actually look at anything of any decent size, these dependency graphs are a great way to intuitively look at it as a human, but in reality, the amount of information you can get from this graph is quite low. You can see some interesting things. You can see this sort of tree-like structure going on. If I highlight things, you can see the way that they depend up and down. So there's definitely a kind of layered architecture. This is what a layered architecture looks like when you do this kind of stuff with NDepend. But like I said, ultimately we need something better to view these sort of large structures. Something that's been added since I started writing this talk is this little hint up the top, which is fantastic. And it says basically, this is too hard for you to look at. Try using the dependency matrix instead, which is really helpful until you try and make sense of that. To be fair, there's some really great guidance in the NDepend documentation that tells you exactly how to read this and how to read it in useful ways. And I'll show you that quickly today. Basically, what you're looking at here, and I won't even bother zooming in so that you can read it, but across the top here, what you've got is all the types inside this, inside the analysis, or inside the, what did I zoom in on, the namespace, inside this namespace, right? So they're all across the top. They're also repeated down the side. And if there is a dot, that means that the string assert class over on the left depends on the does class on the top. And you can tell that by the fact that the arrow points from the left and up. If I was to come down here, we've got, well, it's actually over here, you've got the same dependency, but back the other way, represented the other way. So you tend to get mainly symmetrical views like this along that diagonal because it's repeated in both dimensions. So that's what we're looking at, and then that's great. How do I make sense out of that? Well, there's a couple of interesting things we can see here. The first thing we can see is these big long lines. So these big long lines are generally going to be a problem. Right? What you see when you see a big long line like this is that almost everything in this namespace is going to depend on this type. That means any changes to that type are likely going to break everything else or anything else in this namespace. This is an interesting case because if you actually, oh, sorry, don't do that. How do we view it? Oh yeah, there we go. It's actually an empty class. So this is probably just used for reflection or something like that to load things up. So it's a little bit of a false positive. But if this was actually doing something meaningful, it would likely be something that we might want to look at ways to refactor it. The other thing to look at on the graphs like this are groups like this square, not necessarily a hollow square. This one also is very interesting. What this basically says is that everything in the borders of this square, and they're very rarely as well defined as that, but everything within those borders are dependent on each other. And especially in the case like this, where all this is blacked out and there are no dependencies sort of on the cross horizontal and vertical, this is a really highly cohesive group of types that don't depend on any other types in this namespace, so I'll probably be a candidate for removal into another one so that dependencies don't grow between these types and other types where they shouldn't. This one's a little less clear, but still, you know, it'd be worth looking at why that type that I've clicked on there, if you follow the red line across the left, doesn't need to depend on all those other types, or can we separate that somehow to make this an independent group of types? So if I was to open one of the types in this group of types here, okay, and it so happens that the reason these are all dependent on each other is they're part of a class hierarchy. So if I follow this up to the top of this hierarchy to our parameter data source. I can then right-click on this and open up the NDepend menu, where I can then select all the types that use this type directly and indirectly. So again, we're looking at dependencies of this type. And so if I select all of those as in query that NDepend will generate for me, I can export those to a graph. And now what I'm looking at on this graph, no, that's the wrong one. Let's try that again. Oh, sorry, I just need to actually limit it to that namespace that I was looking at before. So where t.parent namespace, no, parent assembly will be easier. .name NUnit framework, because I'm just excluding all of the test assemblies and all that sort of stuff as well. So that's brought it down to about 40 types. So if I export that to a graph, it's a little bit more sensible to look at. And what I'm now looking at is the graphed version of this cohesive group of types and these other couple that have sort of been pulled in here, right? And all of their dependencies as well. So what you end up with is this tree here. This is that hierarchy that is that really clearly defined square. And you can see that just through this one dependency here, it's linked to a whole nother tree of types. So this would be an example of how I've now used the dependency matrix and the dependency graph to get a really good understanding of the fact that, you know, this group of types and this group of types are linked, but only by a very small amount. So maybe there's a way that I could employ some other kind of pattern or something to break that dependency and therefore get some more flexibility in my code. So those are the two main views we're going to be using today as I go through the exercise of breaking up that code. There is one other one that I have not had much use for, but I will bring up really quickly just so that you're aware of it for completeness, I guess. If I open a query like this, so this is just all the assemblies that we've got analyzed at the moment, and open them in what's called this tree map. This is like a heat map of all the types. What you're looking at here is a series of squares. Each square represents an assembly, and then a square inside that would represent a namespace, and then the smallest unit of square, which is down there, is a method. And that's because I've got selected the method level in this box. The size of the boxes is the size of the code, so the number of IL instructions in this instance. And then the color is the cyclomatic complexity. So we've sort of defined 56, and cyclomatic complexity is just a bit of a heuristic on how complex the code is for anyone that's not familiar with it. We've decided 56 is red. I could easily say that I don't want anything over 27, and then that would give us things to further investigate. All right. So, back to the spaghetti I've been talking about this whole time. So basically, what happened to me and my team was that we basically inherited a bunch of code. And the people who wrote that code at some point were given some, what I like to call the victims of architectural advice, in that someone at some point decided to tell them that, hey, you should put your code, your business logic, in a business layer. So they did. They created one class and they called it the business. And then they proceeded to just sort of put all the code into that over time, because that was what they were told they should do. I suppose there wasn't really much context provided. So what happened is, of course, that over time this class grew and grew and grew and grew. Not only did it grow outwards in size, it sort of grew inwards as well. And by that I mean that you had small little methods refactored out that didn't really make much sense in the business context, and you had other methods reuse parts of other methods that really probably shouldn't have. And what happened is basically it just became very hard to really follow all the code through one transaction. it got to the point where the team were still managing to make changes in this code, but they were happening very slowly. And ultimately, we were kind of worried every time we make a change about if we'd broken anything else, because everything depended on each other. There weren't any unit tests over this code, so refactoring it also was very difficult because we couldn't tell if we'd broken something else by trying to refactor one single thing. What we were really trying to do is just do what I call compiler-safe refactoring. So that is, extract methods onto a new type, or rename methods, or break methods into small methods and that sort of stuff. But like we said, we couldn't really even do that because we were worried about breaking other things. And that's where NDepend sort of came in to help. So what I'm going to open up next is sort of a simulation of that. So what I've got here is I wrote some code that basically just generated a bunch of types, which I'll open here. So I've got my God class here. So it's, oh, sorry. There we go. So I've got my God class here in my spaghetti namespace. And so I've just literally just generated a random bunch of methods, and these methods randomly call each other, which is a rough approximation of the kind of code we were dealing with. It's a little bit harder to follow because the names are actually random. One of the things that will become apparent, though, is that once the code looks like this, it's very hard to start to think about what the domain might look like underneath it. So what I'm going to do first is actually just write a query and show you what the dependencies between these methods looks like. So if I need to open the project, let's just open that one. And I'll just analyze. Okay. So I'm going to, from M in methods. Can you guys read that, or do you like me to zoom in on it? Up the back? Seems okay. From M in methods, where m.parent namespace dot name equals spaghetti. Select M. I probably spelt spaghetti wrong. All right, there are all the methods. This is open. This is the N unit assembly. I've opened the wrong project. Okay. There we go. All right, from M in methods, where I'm actually going to go m.parent type dot name equals God, because it's easier to spell. Select the methods. So there we go, we've got 25 methods, and if I export those to a graph, you can see this is not the right graph. I need to build and analyze again. That's from my last practice run last night. Okay, so we've got 47 now, and this is what the graph looks like. So this graph's really right on the edge of something that might be useful. I mean, we can see some interesting things like, okay, everything's sort of dependent on this statement, and there's a bit of a hierarchy going that way. But it gets tricky because we might say that, you know, there's almost another tree growing out over here, but it sort of starts to get tangled. I'm going to turn that tooltip off. Starts to get tangled in through here, and we really, you know, can't separate these two very clearly. So instead of viewing this on the graph, of course, I'm going to go and reach for the dependency matrix instead. And from here, to me, the most obvious thing that immediately jumps out is obviously this giant line. So that's the stateless method that you can see. And what I'm going to do today, and what we looked at doing as a team, was actually just to begin by extracting these methods into separate classes. One of the biggest problems we've got going on at the moment is that all these methods, because they're all next to each other in the class, they can all start referencing each other more and more and more. The first thing we want to do is start breaking that up and just elevate the dependencies to a class level so that we're not looking at every possible dependency at once. In a real scenario, you might be able to use some more imaginative refactorings than this. We use things like in the end of passing in function parameters to other methods and stuff like that to do some better refactorings. But today I'm just going to extract things into different classes, and maybe we can see if that provides much value or not. So I'm just going to follow this through. I'm going to grab this stateless method, and I am going to put it into a new class. I guess as well, something that we did is you could sort of run along and see what else is going to come with this as you grab it and see whether it's something you wanted to do. One of the things that my team got as a benefit by using NDepend to do this kind of thing is not only were we able to see the places to make the cuts better, but we were able to get a little bit of a look into what it's going to try and look like to pull those methods out. In the past, what we often found was that as we tried to do a refactoring like this, a large-scale refactoring like this, we'd sort of get half a day, 2 days in, start to worry that it wasn't going to work, and we'd sort of chicken out and stop it. In the end, what this allowed us to do is have the confidence. We spent about 2 to 3 weeks mobbing on this as a team of about 5 people, and by the time we got to the end, we had the confidence all the way through that we were actually making progress, and this was a good thing to do. I'm just going to call this class state, even though it's got a method called stateless in it, because the methods are all just rubbish names anyway. And I'm just going to follow this through and grab the methods that it needs and pull them across. This does become a very mechanical process. Became quite boring to do over a course of 2 to 3 weeks. But what does start to happen as you do this is that the methods you pull start to give you an idea of what this class is. So, you know, whatever these 4 methods add up to being, that will generally start to become a domain concept that you can do. So I've grabbed all of these now, and I know that I've got everything that's required by this little group of methods in this class. So what I need to do now is go and fix all these references. So I'm just for the sake of demonstrations going to pull in a class and just create an instance of it so that all these things can be used. Just do a quick find and replace. Oops, too many underscores. Hopefully that'll all go green. And then there's a couple of other instances. I've managed to get a V in there. What's going on here? Readable needs to be public as well. So there's readable as well. What we can do now, though, as well, because so stateless needs to be called from outside of the class and readable does, but we can make these two private. And we can tell that because nothing breaks. So again, we're using the compiler to verify our refactorings all the time. And that at this point allows us to refactor under stateless and readable in any way we want, with knowing that we didn't break anything else. And this is where we derived a lot of value out of going through this exercise. At the same time, while at this point, the God class is maintaining a dependency on the stateless class, over time, as we replace all of this stuff, we'll hopefully see that the God class might actually evaporate, and that one point of coupling might just start to disappear. So now that I've done that, I'm going to rebuild and reanalyze, and we'll take a look at how those graphs have changed. I'll actually pull it up so that you can see it change. This is what it looked like before. Then when we run a new analysis, this is what we get now. So not a lot better, but we can start to do things like see little groups like this down here. I don't know how easily you can see that, but to me, if I sort of squint and look blurry, there is a group of methods down here that I could start to extract. So I'm going to select one of those, and I've obviously gone through and had a little bit of a look at this earlier, and you can see by following the cross members here that maybe it's not such a bad method. There's nothing on the vertical that's going to come with it when I try and grab that. And there's only a couple of things over on the left when I try and grab that that's going to come that's not inside this little group. So I'm hoping that that would be a good candidate for me to try and extract another group of sort of highly cohesive methods. So if I follow this through, this is based here, so I'm going to grab that. I'm going to put it in a new class called, I don't know, base class or something like that. Something sensible like that. And just go through, grab all of these. If anyone's got any questions at this point, I'd be more than happy to talk and answer the question while I do this. Yeah?
Tools that would let you just grab something from that matrix and do this for you?
I mean, I don't think so. The method I'm describing here isn't really the way to do it. Huh? Sorry, yeah, of course. So the question was, is there any tool that would be able to do this process for you, this process being taking that dependency graph and grabbing all the things out of it for you? Thanks for the reminder. And the answer was, no, I don't. Not that I'm aware of. I think one of the reasons why that tool doesn't exist is that, while this is a fairly straightforward way of doing it, I'm not sure that the 100% mechanical way I'm going about doing it today, and that is by just sort of extracting everything in classes and letting those classes depend on each other, is really the exact way you go about doing it in practice. You'd probably look for, more appropriate ways to do that kind of refactoring. Which one was that? Say that again, sorry, I can't quite hear. Okay. So you think invalid needs to go back? Let's see. Iterable is what I wanted. Whoops. Now we're in trouble. Ah. Maybe I shouldn't have tried to answer questions while I was doing this. Okay, driven we did want. Great. And then iterable we want as well. There it is. Okay, so this class actually needs to, and this is the sort of the downfall of this method in that it sort of, you know, starts to bring all, it's still tangled at some level, right? State S. And this is called base class, so I'll add this up here. And this one's a little bit more manual, but there's not as many. So we did based, we did iterable, principal, invalid, so if I have a look at this, then I'd want to make, I think I can make this one private. I can tell by looking over on the scroll bar on the right, nothing broke. Invalid was definitely, I think, used, was it? Yeah, that broke something. And so obviously it's really important that at every step we make all of these private that we can. Was iterable? Iterable we can't make private either. So only one made private at this point. But what that has allowed us to do is, again, to cut down on the number of types or methods in the original class. So if I rebuild there and then actually run the analysis again, we get to have a look at the improved graph. Now this is starting to become a little bit more sensible and understandable now that we've sort of taken those two things out. Whether they were great cuts to make or not, the intuition's a little bit harder to use on the dependency matrix. But what we can see here is that this statement looks like a really good separated class, except for the fact that it starts to cross over at the abstract method and the simple method. So this is where we can start to make some more sensible choices about the refactoring. And what I'm going to do is, for the sake of quickness, I'm just going to grab abstract and simple out into their own class. We'll just call that a common dependencies class or something like that. And then that's going to allow us to get that whole tree out without pulling all of this one too. And this is where we really started to see the domain model start to emerge out of this mess. So if I find, actually I can do it back from here, if we find simple, and then abstract, and they're going to need those two dependencies, which are, oh, abstract's going to take aspect with it as well. I know aspect will be able to be made private. So what do I need? I need state and base class. Whoops. And then add this common dependencies to the God class. Right, so then rebuild again, back to the graph, reanalyze. And now we can see that this tree here is completely separated from the rest of it, so I can start to pull that out into its own class as well. So I'll take that, and yo. Yeah, sure. So one of the things you can start to see in the matrix is you start to see a little bit of clear air developing between the types as well. So if I'll find statement for you. There it is. So you can see that statement's got no dependencies on anything else. That can't be right. Statement's got dependencies on XML. This group here though, right, this square, I don't hit anything else on the vertical or the horizontal. So you can see that that group of cohesive things now can come out cleanly. This isn't quite clean yet, this group down here. You've got a few little dependencies on it as well. So that would be the sort of the next place you might want to look at why these were dependent on each other and is there something you could do about that. So I'm going to, for the sake of just showing you what this finally looks like at the end, grab this one out here now. This is quite a long refactoring to do because there's a lot of, that's a reasonably big tree that we're pulling out there. But interestingly now, because that's the only public method statement, you know, I start to get an idea, a better idea of what this might be. This might be my statement maker or something like that. We're really starting to see a domain type come out of all this. So I'll just go and grab all of these. You can see that most of the methods in that God class now are actually calling out to something else as well. So my hope would be that that would sort of start to evaporate and all the call sites that originally called the God class could be replaced with calls to the new classes that we're creating here, leaving only the dependencies between those classes as the ones that you need to worry about. The amount of red sometimes you get building up on the scroll bar on the right gets a little scary. I think it's worth noting as well that when we were doing this for 2 or 3 weeks, mob programming was probably a big part of our success as well. What we've found as a team that when we're doing something as a group, when it's a bit scary like this, having the team there to sort of encourage you and keep the courage levels up. When one person's ready to give up, someone else has got the energy to press on and that sort of thing. So might also be worth noting. Okay, and then we need state, base class, and common dependencies. Now I don't need to go and change the God class because I pulled everything out this time, so it's completely separated from it. So I should be able to build now. And then, you know, this is not going to change a lot here, but if I reanalyze, obviously all of those types will disappear. And we start the problem over again, and we start to say, right, maybe this looks like a good one to grab out, auto wire. You know, what can we grab, or is it JMS that's only got one link through scope? So maybe scope can become a common dependency, and then we've got 2 more trees to grab and that sort of thing. One of the reasons I really wanted to finish that refactoring as well is because originally, if you remember, when we had the 45 methods in our original thing, we had that really tangled graph of the methods between it. We can now start to do another graph. And if I start a new query here, I'm actually going to say from T in types, where T.parent namespace equals .name equals spaghetti, hopefully I'll spell it right, select T. Before we were trying to work out which parts of our code depended on each other by querying the methods inside the single God class. Now that we've elevated those method dependencies to be actually method dependencies between classes, we can start to run the query of how those classes depend on each other. And we start to get a graph like this, which is, while obviously still a mess, much more easy for us to reason about and start to decide how our domain concepts depend on each other. This is obviously pretty random because I randomly generated it, but when we did this with our real domain classes, things started to become clear about what should and should not depend on each other. Okay, so that's the end of the demo today, and pretty close to the end of the talk as well. What have we got left to say? So I suppose, I mean, I've actually probably iterated this fairly well throughout the demos that what we did here today was much simpler than we did in real life. It was a smaller problem. It was one that I'd tweaked a little bit so that it worked well today. There were a lot more dead ends and backing up going on when we did this as a team, as well as there were some more thoughtful decisions about the kinds of refactorings we did rather than just extracting everything to classes and having those classes depend on each other as well. Yeah, and so that's what I wanted to show you guys today. Thank you all for sitting through some lengthy coding sessions there. I'm glad it all went well. I'm more than happy. We've got about almost close to 5 or 6 minutes left now to take questions if anyone's got any. Yeah.
Did you find many bugs while doing this?
Did we find many bugs? Yeah. I understand. So the question is, did we find many bugs while we were doing this kind of refactoring? No, I don't think we did. I mean, if we were to be adding better types to things, or if we didn't actually read a lot of the code, to be honest. We sort of looked at what that method calls that method. Yeah, just pull it with it. And so any bugs that were in the code just kind of came with the code. What we did find was a lot of dead code. We found a lot of code that sort of called in circular ways that shouldn't have, and so we could cut it off there. And we found duplicated code as well that maybe shouldn't have been. So we did find those things as we went through this process. Yeah. Did the functionality of the code change? So because the question is, did the functionality of the code change after we refactored it? No, it didn't. So it was purely a functionality preserving refactoring we were trying to do. Because we didn't have any unit tests and we weren't really sure, considering the amount of refactoring we did over sort of 3 weeks and tens of thousands of lines of code, we did do a full manual regression test, or a light manual regression test over the whole code base, and we didn't find any bugs either. So maybe 1 or 2 or something like that were just copy-paste errors. So it was a pretty reliable way to do it. Yeah. Yeah, right. So the question is there a scale issue with NDepend? Now, I'm going to answer it in 2 ways, and hopefully tell me if I don't answer the question correctly. In terms of how much code can it physically crunch through and analyze, it's pretty good. I mean, I've run it over some fairly big projects. It takes a little while to do that first analysis. But when it does that first analysis, it builds a big in-memory model of it. So the querying after that is always quite quick. So it might get slower on the initial analysis, but the querying is always very fast. So I'd often as well, because we were working within one class, I limited the scope of most of the assemblies that we loaded to just a single assembly that we were working inside of as well. The second way I might have interpreted that question, though, is how does this NDepend scale in terms of being able to a human interpret it once the code gets to a certain size. And that's largely what we've been focusing on today as well. So while NDepend can actually load in a lot of code, often there's not a lot of point loading in too much code because you can't understand it anyway. At some point, that dependency graph becomes too small to read as well.
So you say you have to start on the class level to break up the monolith, or what if you want to break up, like you want to analyze assembly dependencies and
Yeah.
rid of some assemblies into some other repository?
Yeah. So that comes back to this, right? Every other time I picked up NDepend out of general frustration, I've not made much headway with it because I've not known what I was trying to do. In this scenario with this team, I knew that we had one giant God class, and what I wanted to do was break up that class. You might have a different problem. You might have one assembly that's too big and it's slowing down your build process. You could use a similar process to the one I've shown you today, but it might be at a slightly different level. So, you know, I guess what I'm trying to show you is one thing that we did very specifically, but also hopefully you can see that how you might be able to abstract this method to suit what your problem is. Yeah.
What about like indirect dependencies, perfections, whatever?
Yeah. Yeah, so indirect dependencies. The question is, what about indirect dependencies when you use reflection and things like that? So obviously they can be a bit of a problem. NDepend does some interesting things though. There's one particular metric in it that, and I'll bring it up, something about dead code here, right? Potentially dead types is what it's called. So it finds potentially dead types or potentially dead methods and that kind of thing. And it defines quite a complex query to define if something is depended on by anything else. And the way this actually defines if something's dependent on doesn't just look at the code and see if there's a reference to it. It actually checks if the code can compile without it. So if there are compile time dependencies on it somehow as well, that kind of thing will fail too. But reflection, I think, would probably be outside the scope of what NDepend can do, as far as I understand it. Okay, we're probably done. Thanks so much for all your time today.